Okay, so I am explaining assignment 4. It revolves around decks, not to be confused with DQs, because DQ is an operation of a deck, but deck stands for a double-ended queue. So before we get into the implementation here, this is the interface, the deck interface. So this interface basically just tells you the abstract function headers, which just tells you the return type, name, and then arguments. So here it has three. It's made of the DQ is made of three variables: front, rear. These are two double linkless node types, and they have their own implementation further in the further lower levels. And then the protected int num elements here. This basically tells you how, we'll use this later to determine how big it is. So here we got the constructor. It just basically sets front and rear to null, and then is empty, and then size are pretty self-explanatory with O of 1. That just returns the size and if the DQ is empty. So in Q front, this is the first function of note that I implemented. So here we make a new node, and if the front node is null, meaning that it's empty from the front side, or empty in general basically, we make front the new node, and also we make the rear the new node, and we bump up the elements. Now, in the case where it's not empty and it's pre-existing, we simply we set the new node's forward pointer to the front, and then we set the front's back pointer to the new node, and then finally we make front the new node itself, and then we add num elements. So we increment the counter by 1. And then same principle with the NQ rear. It basically checks the opposite. So it checks if it's empty on the rear side, or empty in general. Then rear would be the new node, and then front would also be the new node, and then we'd increase the number of elements. And then if it's not empty, we would set the back pointer, we'd set the new node's back pointer to the rear, the previous rear, and then we would set the previous rear's forward pointer to the new node, and then we'd finally make rear our new node, and then we increment an element number to it. Now DQ front, so DQ is the opposite of NQ, and of note it returns type T. So T info equals null. This is just here to return eventually. And if front is null, or if the list is empty, we return null. Or there could be a throw, or we could throw an error, a queue underflow error, but I tried to do that, and for whatever reason it wasn't implemented, and I didn't know if we were supposed to implement it or not. So if it's not empty, info is front.getInfo. So we just take the info of the front, and then we set front to, and then essentially we delist the front. So we make front the next linked element, and then we go down one num elements here, thus updating the counter, and then we return the info. DQ rear, similar principle here. We get an info, and then if the rear is null, we return null, and then anything else we return. Or wait, first. Yeah, so we get the info from the previous rear, and then we make the new rear the element before that rear, and then we increment down an element and return the info. Now, The palindrome checker, this is somewhat new, or this is somewhat a creative use of the deck data type. So inside of it, we make a deck ourselves here, and this is a character type deck called charQ. So we take input of string s. So this for loop increments through every character of that string s, but we check if the char at I is a letter, and if it is, we enqueue it either to the rear or front, and then we to lowercase it. So that makes it all consistent. So this is here to eliminate any punctuation or special characters. We're just making sure it's letters, and then this to lowercase here, that makes sure that everything's consistent for capitalization wise. And then this function here, it prints out our we reuse the toString method here, and it prints out the current char queue to show the input and what has been inputted. So then this is where the magic happens. This is where we check if it's a palindrome or not. It's quite an elegant solution. So we check first if the size is bigger than 1, and then so we dequeue the front element, and then we dequeue the rear element. And if these are not equal, then it's false. But then if it's true, we increment through the loop again until it shrinks down to 1 or 0. And it's very pretty, and I'll show you later how it works. And then if it makes it through all the dequeuing and it's less than 1, it will return true. And then the toString method here, we use a copy of the front node, and then the result is just a blank string here. And if it's empty, we just say the queue is empty, and then else, well, I didn't make use of the isEmpty function now that I'm thinking about it, but it's all the same. Else, so then else so for the first element here, we'd say deck front, and then while the current node does not equal null, we add the current node's info to the result. And then this if else conditional here is to draw the arrows, and then if the current node is the last one, we just say rear and then \n. And then this current node here is here to make the while loop work. So once it gets the info, checks the conditional, and then gets forward, and then it continues that while loop, and then we return the result. So here I'm in the driver program. So I made a deck of integer type that's called I, and then I enqueued front 6, and then 7, and then I enqueued rear 69. So we should see when we run it here, we should see we should see yep, we should see. So we enqueued 6 to the front. I was briefly confused there. And then we enqueued to the front 7. That is supposed to happen. And then we enqueued 69 and the last one by the rear. And then the toString method works here because front, rear, and it's all pretty like. Now this is the palindrome part. So if we just type in a random string, it tells us the letters, and then obviously that garbled mess is not a palindrome. Now, if we do like a palindrome, it's a very famous one, race car with capital random letters, it does return that it is a palindrome, and as you can see, all the characters are lowercase here. And then the final one, wait, and then there's the Madam test. So then, so Madam, but with the first A is an at symbol. It's not a palindrome because that's a special character and that gets excluded. And then finally, a man, plan, canal, Panama. Yep. And this big string here is a palindrome, and that is consistent with the instructions. So yeah, that was assignment number 4.